All right, let's take a look at how to solve systems of linear equations in two variables. First of all, what is a system of linear equations in two variables? It's simply linear equations that are considered together that form, it could be two or more linear equations considered together. That's what forms a linear system of equations. So we're going to be finding solutions to these linear systems. And there are three different cases that we're going to look at. Case one, you may come across a system that has one solution, one ordered pair that intersects at one point that's common to both of the linear equations that are considered together. So what that looks like is if you had two distinct non-parallel lines. So we have our XY coordinate grid here. So this is the grid, and then you may have one line that looks like this. You graph it, and on the same set of axes, you graph another line that looks like this. So you have line 1 and line 2 on the same coordinate grid. The intersection of those two lines would be the solution. That is one XY ordered pair that is common to both lines. So that XY ordered pair would lie on both of those lines and be a solution to both of the linear equations. This type of system is called independent. Because the lines are distinct from one another. And it is also called consistent because there is a solution, one single solution to this scenario. The second case that you might come across is you might have something like case 2 here. Oops, let me lock that down. In case 2, we have two lines that are parallel to each other. So think of how many intersections you'd have. Hopefully you're thinking to yourself, they will never intersect because we have this XY coordinate grid. Whoa, that was really crooked when I made that. Let me do this over here. That's pretty crooked. All right, so here's my XY coordinate grid. And if you have one line, line 1 maybe looks something like this. And the second line that you graph on the same set of coordinates, a coordinate grid, is parallel to it, meaning they have the same slope. In that case, there will be those little arrows mean that those lines are parallel. Line 2 has the same slope as line 1, so they're parallel. They will never intersect, and therefore there is no solution. So parallel lines, there's no solution. And the type of system that we call this is these are inconsistent. There's no, let me go in the same order that I did before. These are independent. They are not the same line, so they're considered to be independent lines. And they are also called inconsistent because there's no point that is common to both lines. They never intersect. So inconsistent. And then we have one more case, case 3. You might have an infinite number of solutions. That happens when if you graph one line, and so you graph line 1, it looks like this, and then you have another equation. Maybe it's in a different form. Maybe one's in slope-intercept form, the other one is in standard form or general form. You end up graphing it, and it ends up being exactly the same line. Well, how many solutions, how many XY ordered pairs do they have in common? Well, it's an infinite number. Every single ordered pair on both lines lies on the other line. On either line lies on the other line. This system is called dependent because they are the same line, and it's also called consistent because there is a solution. There's an infinite number of solutions. Every single point that lies on the blue line is also on the red line. Okay, so these are the steps for solving systems graphically. We're going to look at in this section, we're going to be looking at solving systems graphically. Then we're going to look at solving algebraically, two different methods there. We're going to solve using substitution, and solve by elimination. So these are the steps if you want to solve by graphing. First, I recommend that you write these steps down. First step is you're going to graph the first equation on a coordinate grid. Then the second step here is graph the second equation on the same set of axes, and then determine the coordinates of the point of intersection xy. Where do they intersect? Determine that xy ordered pair, and then put that solution to check your answer back into both equations to see that it makes both equations true. If it doesn't, then something went awry along the way, and you got to go back and try to find where you made a mistake. Okay, so make sure you get all these steps written in your notes. And then let's look at putting it into action here. All right, so we're going to solve this system by graphing. So example 1, you have y equals 1/4 x plus 1. And the second equation here is 2x minus y equals 6. So notice the top equation is in slope-intercept form. So we can directly graph that using the slope and y-intercept. And so my y-intercept is 1, so I'm going to put that point on my graph. And my slope is 1/4, so when I go up 1, I'm going to go over 4. And I can keep doing that. And I can go back this way, down 1, and to the left is negative over negative, which makes it positive. So I'm going to throw that line in there. Looks like that. Make sure, well, I guess with the computer it will put the arrows in for you, but choose the line function, not the ray or segment. Okay, the second equation here is written in general or standard form. The easiest way to graph it, you could rearrange it and put it into slope-intercept form if you really wanted to, but you could also just find the x and y intercepts. Hopefully you remember how to do that. What we're going to do is we're going to find we can find our x-intercept by letting y equal 0, and we're going to find our y-intercept by letting x equal 0. Because if you think about, if you're on the x-axis, anywhere on the x-axis, so let's pick a random point, the y-coordinate would be 0. If I move that point anywhere on the x-axis, the y-coordinate is 0 because you have not moved up or down. So you're going to find your x-intercept where it crosses the x-axis by letting y equal 0. And likewise, if x is 0, then you're somewhere on this y-axis. Anytime you're on the y-axis, the x-coordinate is 0. So we let the opposite variable equal 0, and we're going to solve for, in this case, right here, we're going to solve for x. We're going to put in 0 for y, so I'm going to have 2x minus 0 equals 6. So I'm trying to figure out where 2x is equal to 6, because I don't need to subtract the 0. Divide by 2, and we get x is 3. So we have this point, my x-intercept. I'll move this over here. We have the point, the xy ordered pair is 3, 0, which is right here. And then if I put in 0, let me do this in a different color. If I put in 0 for x, I would find where it crosses the y-axis. So I'm going to do that by, I'm going to put 0 in for this x, and I'm now going to solve for y. So 2 times 0 is 0, so I get negative y equals 6. If negative y equals positive 6, then positive y equals negative 6. Divide both sides by a negative 1, if that makes more sense. The negatives cross out, and you get y equals negative 6. So when x is 0, y is negative 6. So the point 0, negative 6 is the y-intercept, which is right here. I got 2 points. That is plenty enough to draw in the second line. And then look at where these two intersect, and you'll see their intersection point is right here. The x-coordinate is 4, and the y-coordinate is 2, it looks like. So 4, 2 should be our solution to this system. In order to determine that it truly is a solution, we're going to check 4, 2 in both equations. So you should be in this habit, and you'll know before you click submit whether you have it correct or not. So I'm going to put 2 in for y, so I'm putting it into this top equation here. I'm going to call this equation 1, not negative 1, 1. And then this equation, I'll call that equation 2. We're going to check it in both 1 and 2. So I'm putting 2 in for y, and I'm going to put in 4 for x. So I'm going to make it 4 over 1 since I'm multiplying by a fraction. Plus 1, so that is, I'm checking it, so I don't know that it's equal. This cancels out to 1, 2. Does 2 equal 1 plus 1? And of course, yes, it does. So that checks out for that equation. But then we also want to check, so we checked it in equation 1. To be sure, we also want to check it in equation 2. So I'm going to put a 4 in here and a 2 in here, see if it gives me 6. So 2 times 4 minus, minus the y value is 2 from that solution. Does that equal 6? So this is 8 minus 2, which, yes, it equals 6. So that is how you want to, those are the steps. Graph both equations, find their solution, and then check it. So try to do this one and come back to see if you get the same thing I do. Okay, so the top equation, number 1, has a y-intercept of 0 because there is no plus b. So m is 1/5, the slope is 1/5, the y-intercept is 0. So it goes to the origin, and you go up 1 and over 1. You can keep doing that up 1 and over, up 1 and over 5, because 1 over 5. And then this is another point on that line. You can go down 1 and to the left, because that's a negative over a negative. And do it again. You get that blue line. The bottom equation, number 2, has a y-intercept of 2. And right here, and the slope is negative 1/5, so you drop 1, go down 1 and over 5, you end up right there. Keep doing that. I graphed a few points, and then I drew in the line, and the point of intersection that I found was 5, 1, right here. The x-coordinate is 5, the y-coordinate is 1, and I checked it in both solutions, putting in 1 for y and 5 for x. You get 1 equals 1/5 times 5 over 1. 1 equals 1. That worked out. And then same thing for the second equation. You get 1. Does that equal negative 1/5 times 5 plus 2? And it did. It's a plus sign. Because negative 1/5 times 5 over 1 is negative 1. Right here. And then negative 1 plus 2 is 1. So it checks. All right. So I'm almost out of time here. I'm going to do another graphing one in the next video, and then we'll look at solving systems algebraically.